by definition, a function f of x is continuous at a number a if the limit as x goes to a of f of x equals to the value of the function at a. Now in this case, this limit is a two-sided limit. So the way we'll read this is, as your x's get close to a from both the left-hand side and the right-hand side, the y values of the function f of x will get closer and closer and closer to the value of f of a. So we can highlight this idea in the following example. Suppose that we have a function here in purple. This will be our f of x. And suppose that we're trying to see if the function is continuous here at the number 3. And suppose that if we plug in 3 to the function, we get the number 4 for its y value. So as my x's get close to 3 from the left-hand side, the y values of my function will get closer and closer and closer to the number 4. And as my x's get close to 3 from the right-hand side, the y values of my function will get closer to the number 4. So whether I'm coming in from the left or from the right, the y values of my function are going to the number 4. So in this case, the limit as x goes to 3 of my function is equal to 4, where 4 is the value of my function when I plug in 3. So in this case, this function is continuous at 3. Compare that to the following example. In this case, let's say our function looks like this. And again, we're looking at whether the function is continuous at 3. Suppose that the heights here are 4 and 5. As my x's get close to 3 from the left-hand side, the y values of my function are headed towards the number 4, which is not equal to the value of my function, where the value of my function is actually 5. And from the right-hand side, if your x's get close to 3, the y values of your function again head towards the number 4, which is not the value of the function of 5. So here, if you take the limit as x goes to 3 of your function f of x, the limit does exist, and the limit is 4 because, remember, the limit is asking where are the y values of the function going. But in this particular case, this is not the value of my function. So here, if we take the limit as x goes to 3 of my function, the limit does exist because the limit is asking where are the y values of my function headed as x goes to 3, and in this case the answer would be 4. But the number 4 is not the value of my function, is not f of 3, where f of 3 is equal to 5. So in this scenario, the function is not continuous at the number 3.